first step in solving any word problem is to assign your variables. In this problem, we know we're looking at consecutive odd integers. So we can name our first variable I and our next variable I plus 2 because consecutive odd integers are 2 units apart on the number line. Once we've assigned our variables, the next step is to create our equation. We need to look at the relationship in the problem. In this case, we're being told that the larger integer is 7 more than twice the smaller integer. That relationship gives us a lot of indications on how to solve the problem. And we can substitute our variable names. So we named the larger variable to be I plus 2. Is always translates as the equal sign. 7 more than would be 7 plus, and twice the smaller integer means that we're looking at 2 times our smaller integer, which is I. Once we have the equation, now we can go through the process of solving the equation using the tools that we've developed at this point. The final step in any word problem is to write out your solution in sentence form. In this case, our integers are -5 and -3. Once you know the first integer, which we found by solving the equation, we can find the value of the second integer by plugging it into the expression that we created at the beginning of the problem to identify the larger integer. -5 plus 2 is equal to -3. Once again, in this problem, the first step is to assign our variables. In this case, we're looking for 3 consecutive odd integers. So just like in the last problem, consecutive odd integers are 2 units apart on the number line, so our assignment begins with letting x be equal to our first integer. Our second integer is x plus 2, and our third integer would be x plus 2, our second integer, plus 2 more, which we can simplify and just express as x plus 4. Once we have our variables assigned, we can write our equation. In this case, the equation that we're going to write comes from the information that we're told that our second integer plus our third integer is equal to 4 times the first integer. We can substitute in the variables that we assigned and then go through the process of solving the equation. Once we have the solution, now we need to go back and answer the question using a full sentence. Our integers are 3, 5, and 7. The value of 5 is found by taking the value of x that we found in our equation, 3, and adding 2. 3 plus 2 is 5. The value of 7 is found by taking the value of x and adding 4. Assigning your variables is important because it gives you an opportunity to record what you will be using at the end of the problem to answer the question. In this problem, we're not looking for consecutive odd integers. Now we're looking at just consecutive integers. And consecutive integers are 1 unit apart on the number line. So we can allow our smallest integer to be x, our middle integer becomes x plus 1, and our largest integer, x plus 2. Once we have our assigned variables, now we can create our equation. Translating the problem, we're told that our smallest plus largest, or the sum of the smallest and largest integers, is equal to 25 more than the middle integer. And once again, we're going to substitute in our variable assignments for the values that we have. Once we have our equation, we solve the equation. We have an answer, and we can express our answer with a sentence. In this case, our integers are 24, 25, and 26. And again, the values of 25 and 26 are found by taking the value of x and plugging it back into the assignment of variables that we found or that we set at the beginning. In this problem, the fact that we're looking at a triangular traffic island really doesn't matter at all. The important piece of information is that we're looking at consecutive integers. Once we know that we have consecutive integers, now we can go through the process of assigning our variables. So in this case, we can let p be our shortest side, and because we're looking at consecutive integers, each will be 1 unit further along the number line. Our middle side becomes p plus 1, and our longest side p plus 2. We are told in the problem that we're looking at the perimeter. It's important that you know what the word perimeter means. Perimeter is the sum of the length of the sides of any figure. Because we have a triangle, that means we need to add together the shortest, middle, and longest side. And we're told that the perimeter is equal to 66. Once again, we have an equation, and so we can go through the process of solving it. Now that we have our solution, we can go back and apply the solution to the context of the problem. Our sentence should express the units of the problem and some of the context of the problem. The sides are 21 feet, 22 feet, and 23 feet long, answers the question asked in the problem. Just like in the last problem, we have a context that we need to consider, but not really until the end. At the beginning, what we need to be concerned with is the fact that we're looking at a rectangle, we're considering its perimeter, so we know we need to have an expression for its length and its width. When we go to assign our variables, we need to look at the relationship between those two values because we're not looking at consecutive integers or consecutive odd or even integers in this problem. What we are told is that the width is 30 feet more than the length, and so we can express our variables this way. There is an equation that expresses the relationship of perimeter in a rectangle. 2 times the length plus 2 times the width is equal to the perimeter. But you could also write this equation as length plus width plus width is equal to the perimeter. Either way will work. Once we have an equation, we go through the process of solving it, and we answer our problem with a sentence. Our garden is 35 feet long and 65 feet wide. It's important when you answer the question to make sure that you assign the length and the width correctly. In this problem, we're told that the width is 30 feet more than the length, and so it's important that in your answer, your width is the bigger of the two values. Just like in the last problem, we're looking at the perimeter of a rectangle and the relationship between the length and the width. So when we go to assign the variables, in this problem we're told that the length is 6 feet less than twice the width. And so we can express our variables like this. Just like the last problem, we're looking at perimeter and we're looking at a rectangle. So when we go to create our equation, we're going to use that relationship and the assignment of our variables that are specific to this problem and the perimeter of the rectangle that's specific to this problem, and that creates our equation, which we can then solve. Once our equation is solved, we can go through the process of writing the solution in a sentence, being careful to use proper units and proper context. In the original assignment of variables, and in the problem itself, we are told that the length is longer than the width. And so in our problem, when we answer with our sentence, we need to make sure that the width is smaller than the length on our chord. In this problem, we're not looking at geometry like we have so far, but we're looking at a relationship between the number of men, women, and children in the group. And so when we go to assign our variables, we're going to begin where C is equal to the number of children. The only reason we make that decision is because the number of men and the number of women in the problem are expressed in terms of the number of children. We're told that there are 4 times as many men as children and 2 times as many women as children. Because children is where we are comparing everything else, it makes sense to let our variable C be equal to the number of children. We know that the number of children plus the number of men plus the number of women in the problem gives us our total group. While that's not explicitly stated in the problem, that's the relationship that we need to find in order to be able to create our equation. Once we have our equation, we can solve it, and we can answer with a sentence. In a problem like this, it's important that you check some of the criteria of the problem. For example, it wouldn't be possible to have 38 and a half children. The answer in this problem has to be a whole number. We had 38 children, 172 men, and 76 women. When we check, we should check to make sure that 38 plus 172 plus 76 gives us our total of 266 total people. When we go to solve this problem, we know that we're going to be looking at the lengths of these three pieces. What we need to consider is, what do we want to assign our variable to be? Because in the problem, the first piece is related to the second piece, and the third piece is related to the second piece, it makes sense to let P be equal to the length of the second piece. From there, it isn't difficult to assign a length to the first piece and to assign a length to the third piece. It would be possible to allow P to be the length of the first piece, or to allow P to be the length of the third piece, but then the assignments of the second and first or the second and third becomes more challenging. The first piece plus the second piece plus the third piece gives us our total board length. We have our equation, so we solve it and answer the question in terms of a sentence. The pieces are 23 inches, 27 inches, and 46 inches long. The most common mistake in a problem like this is to answer the question with no units. Make sure you include the proper units in your solution.